So section 4.1, simplifying radical expressions. So here's a radical. We have a radicand, radical sign, and the index. This index is saying what we're taking the square root of, if the index is 2. The cube root of, if the index is 3. The fourth root of, if the index is 4. So this index is kind of telling us what we have to group by as we're going through. But if we remember way back when we first started this semester, we had rational exponents. This a to the m over n, 1 over n, if we pull out that m, what is this really doing for us? Remember when we were rewriting radicals with fractional exponents, or fractional exponents with radicals? So if we say x to the 3/7, what is this 7 really telling us? If we want to write this in radical form, this is going to equal some radical, but what's the index going to be? 7. So this is the 7th root of x what? To the 3rd. The 7th root of x cubed. So we're going to rewrite these in, with our exponents to radical form, or radical form to exponents. If we wanted to do this one, what is that really saying? If we're saying the square root of x to the 5th, that's going to be what? X to the 5 over 2. Remember, the implied index here is a 2. Okay, so it's x to the 5/2. Our power is 5, our index is 2, so it'd be x to the 5/2. How about 3w plus 1 to the 4/5? Say it louder. The 5th root of what? 3w plus 1 to the 4th. And the 8th root of 2x plus 5 cubed is equal to what? To the 3/8. So our index is 8. So this 2. So if we were rewriting this, 2x plus 5 cubed, then take the 8th root of it, or 2x plus 5, take the 8th root of it, get that answer, then cube it. Okay. So as we go through, we could always do this with numbers too, but you want to make sure, if we say, what's 27 to the 4/3, this one you could do in your calculator. Make sure you have parentheses around that exponent. But what is this really saying? This is saying take the cube root of 27 to the 4th power, or it's saying take the cube root of 27th, get that answer, to the 4th power. It doesn't matter which order you're doing this in, and that's what this up here was really telling you. We could go either direction, as we're going to our radicals and stuff. This one is easier when we're talking about numbers, because it's easier to do the cube root of 27. What's the cube root of 27? 3. And now go 3 to the 4th. What do you get? 81. So this way is smaller numbers, but we could do it this way. You'd have to go, what's 27 to the 4th? It's going to be a pretty big number. And then you're going to do the cube root of it. And what do you get? You're going to get 81 again. Okay. But as we deal with numbers, not everything is going to be a perfect radical. So properties of radicals. This is the product property, saying that if you're multiplying and it's under a radical, you can split this. It's not true for adding, subtracting, but it is true for multiplication or division. And you can think of it this way. We want to split. Now, some of these will have a perfect radical. What is this really saying? The cube root of -8. So it's going to be a cube root of a negative is going to be negative. What times what times what is 8? It's going to be 2. So this is going to equal -2 because, and you could check this, because -2 cubed equals what? It equals -8. So you could always check them. Now, if you wanted to use your calculator, on your calculator, some of you have a fourth root or something. It's under math as you go through. There's a cube root, and then the next one is like an x root. You'd have to put the root in first. Or you could rewrite this as 81 to what exponent? What would we rewrite this to? To the 1/4. So 81 to the 1/4, if you're using your calculator, you better make sure you have parentheses around that. What's 81 to the 1/4 going to be? And this is a nice one. And we could check 3 to the 4th equals what? 81. So these are perfect radicals. It's not going to be an ugly decimal with some of these. Square root of 25. What's the square root of 25? 5. But what's the square root of 50? 50 is not a perfect square. So if we were to go through and we would start 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49. So if we were to start this, if we're looking to simplify the square root of 50, if you put this into your calculator, you're going to get an ugly decimal. This is not a perfect square root. Okay. But when we're simplifying these, we want to have an exact answer here. Not an ugly decimal, not a decimal we're rounding, but an exact answer. How can we rewrite the square root of 50? What we're really saying is, let's split this into something perfect and something not. A perfect square versus not. So if we start with 50, if we look at the 49, is 49 a factor of 50? We're going to go down because I want to find the largest one. Is 36 a factor of 50? Is 25 a factor of 50? Then it's going to be 25 times what? So now we can split this. This is the square root of 25 times the square root of 2. So that's really what this property, this product property was saying. Any radical we can rewrite into some radical times another. So when we look at this now, what's the square root of 25? So this is 5, and then we still have this square root of 2. So the square root of 50 is equal to 5 square roots of 2. If you were to go to your calculator, if you want to check this, put in the square root of 50 into your calculator, get the decimal approximation of that, then go 5 square roots of 2, and get the decimal approximation of that. And what do you know about those decimals? They're the same. They're equal. So how about the square root of 98? 10 squared is 100. So we know if there's a perfect square, it's going to be 9 or less. 9 squared, 81. It's not going to go into 98. We want to find the largest one. It's going to be, if we look back at our list over here, this is really equal to the square root of 49 times 2. So this is the square root of 49 times the square root of 2. The square root of 49 is 7 square roots of 2. So now the cube root of 27. What's the cube root of 27? It's going to be 3. So this is, you could think of this as the cube root of 3 times 3 times 3. For every 3, we get 1 outside. So the cube root of 27 is 3. Or you can make your list as you go down through. What's 1 cubed, 2 cubed, 3 cubed, 4 cubed. And you can see with the powers, they're getting large quickly. What's 4 cubed? 64. Okay. So as we're going to cube root of 54, we're looking for, again, is there a perfect cube in that? Well, 64 is too big. Does 27 go into 54? Yeah. What is it? 27 times 2. So this is the cube root of 27 times the cube root of 2. Don't lose your index, because if you don't have the 3 here, then it's a square root, which is different. What's the cube root of 27? So it's 3 cube roots of 2. But be careful. Make sure you read carefully. This is what? This is the 4th root of 32. And if you want, 1 to the 4th, 2 to the 4th, 3 to the 4th. This is 1, 16, 81. So you can see how they're getting large quickly with the higher the power is. So what's the 4th root of 32? Which one? If there is one. If there's not, then we're done. It's already simplified. But is 16 a factor of 32? So this is the 4th root of 16 times 2, which is equal to the 4th root of 16 times the 4th root of 2. What's the 4th root of 16? The 4th root of 16 is 2 4th roots of 2. This one's left. This one we can simplify. But it's 2 times the 4th root of 2. And again, if you want to check to see if you did these right, you would check them in your calculator. Now, it might be harder to put a 4th root in your calculator, but you could always go to fractional exponents, right? What's 32 raised to the 1/4 in parentheses? Get a decimal for that, and then go 2 times 2 raised to the 1/4 in parentheses, and hit enter. And what should those decimals be if you did it correctly? They should be the same if you did it correctly. Okay. Now that's the harder part. The variables, when we have a variable underneath the radical, this is actually the easier, okay? Believe it or not. But here, as we start with the square root of 25x to the 6, now we do have to be careful when we're doing these, because if the index is even, the square root, we can't take the square root of negative numbers. Those are imaginary numbers. They're non-real. If it's odd, then it's going to be the same. But if we start out with what's the square root of negative 3 squared? Notice here, if it was the cube root of negative 3 cubed, we'd get negative 3. But the square root of negative 3 squared is not negative 3. It's the absolute value of negative 3. It's really what? What's the absolute value of negative 3? 3. And how does this work? What's the square root? Well, negative 3 squared is positive 9. What's the square root of positive 9? You get 3. Notice what we put in, what we got out, were not the same. But as long as they're positive, if x is positive, then you would just get an x here. But if x is negative, you have to do the absolute value of it, okay, for those negative x's. But again, these are your numbers. Now we're going to go through and go the square root of 25x to the 6. We want to simplify this. Now again, if we set this up into two radicals, eventually we will, but 25 is a perfect. What's the square root of 25? 5. And x to the 6 is perfect too. Because if you think of it this way, let's go the square root of 25 times the square root of x to the 6. Now the square root of 25 is 5. X to the 6 to the what? If we're just dealing with this one, what are we going to get here? What can we write that power as? Not 2, but 1/2. And when you have a power, when you have x to the 6 to the 1/2, what are you going to do with those powers? You're going to multiply them. So that 5, that was the square root of 25, times x to the 6 times 1/2 is 3. And if you think of the index is 2, that index is really going to divide into that power. What's 6 divided by 2? It's 3. Okay. Now if there's some remainder, it's not perfect though. But if we could always check this. What's 5x cubed times 5x cubed? What's 5 times 5? 25. And x cubed times x cubed is x to the 6. But if we try that with this one, the square root of x to the 7th, it's not perfect. Perfect means the radical is going to go away. This radical is not going to completely go away. But I can rewrite it with here's my perfect, here's what's left over. If it's x to the 7th, what's going to be the perfect if we're going square root? It's going to be multiples of 2. I'm going to divide this by 2. What's the largest, think of an even number, in x to the 7th? X to the 6th. So this power is going to be x to the 6, because then, what's the square root of x to the 6? We already did it. It's really what? X to the 6 divided by 2, which is 3. However, this isn't x to the 6. It's x to the 7th. If I peel off x to the 6, what's left over? X to the 1st. So this is x cubed square root of x. So when you have a power, what you're really going to do is you're going to divide by that index. That whole number is going to be on the outside. Any remainder is going to be on the inside of the radical. Now that's actually easier. Now, if we say 11, what's 11 divided by 2? This is a square root. What's 11 divided by 2? It's 11 divided by 2. 5 with a remainder of what? With a remainder of 1, right? What's 2 times 5 is 10. How do we get to 11? We need one more. But if you want to continue with perfect versus not, how about 12? Is there a perfect 4? And 4 times what is 12? 3. And if it's a square root, we're going to take the largest even, which is w to the 10th, which means how do I get that extra 1? I got to multiply by w to the 1st. This is my perfect. I can take the square root of 4, w to the 10th. What do we get? What's the square root of 4? What's the square root of w to the 10th? w to the 5th, and then square root of 3w. So when we're simplifying these radical expressions, we're trying to pull out those perfect squares, or cubes, or fourths, depending on what our index is. All right? And square root again. Now again, the powers, the variable terms, I believe are easier than the numbers, the coefficients. Because square root even, what's the largest even in x to the 4th? It'll be x to the 4th. Anything left over for x's? No. How about y to the 13th? Y to the 12th? Anything left over? Y to the 1. But now what about 48? It's 16. So it's 16 times what? 3. So now this I can simplify further. This I can't. What's the square root of 16? 4. What's the square root of x to the 4th? X squared. What's the square root of y to the 12th? Y to the 6th. We're dividing these powers by 2. And then we still have the square root of 3y. So we're simplifying this. We're rewriting. We're taking out all those perfect squares, taking the square root of them. How about this one? So the square root of 5x plus 3, the quantity 5x plus 3 to the 9th. And again, if you want to get in a habit, again, what's our index? 2. So what's the largest one? 8. So this would be 5x plus 3 to the 8th, and 5x plus 3 to the what? To the first. We still have 1. So this equals, what's the square root of 5x plus 3 to the 8th? 5x plus 3 to the 4th. 8 divided by 2. That power divided by 2. And then we still have this 5x plus 3 under the square root. But that's it. You're pulling out the perfect ones, the perfect squares in this case. And we still have 1 left over because this isn't even. What about 4s though? We're going to divide by 4. We want to find out those multiples of 4. If you're dividing by 2, the largest remainder is 1. The remainder is 0. It's a multiple. Remainder is 1. When you're dividing by 2. How about if you're dividing by 4? What's the possible remainders that you could have? Could be, what's 5 divided by 4? 1 and remainder what? How do you get to 5? We need 1 more, right? How about 6? Divide by 5. It goes in once with a remainder of 1. I said divide by 5. I meant to say divide by 4. What's 6 divided by 4? It goes in once with a remainder of 2. How about 7 divided by 4? Goes in once with a remainder of 3. How about 8 divided by 4? It goes in twice, remainder 0. Okay. So if you're dividing by 4, your remainders are going to be either 1, 2, or 3. Nothing bigger. So here, remember this is a 4th root now though, and a 4th root. 20 divided by 4. Is that nice? Okay, so that 20, nothing left over. We're taking them all in here. How about, does 4 go into 15? Well, it does if it's, what's the largest multiple of 4 that goes into 15? It's 12. I just put y, I should say x to the 20th and y to the what? To the 12th. But I got 15 y's. Y to the 15th. So I'm going to have some left over, y to the third. But again, the largest exponent over here is 3. The remainders for those powers are going to be either 3, 2, or 1. Okay. Anything bigger than that, you got to still take the fourth root. If this was y to the fifth, we could pull off another y. Okay. Now what about 80? 16. And again, if you wanted, you could create that list of your 4s. 1 to the 4th, 2 to the 4th, 3 to the 4th. 3 to the 4th is 81. So it's got to be either 1 or 2. 16 times what? 5. So what's the fourth root of 16 now? 2. What's the fourth root of x to the 20th? Take this exponent, divide by 4. What do we get? X to the 5th. Y to the 3rd. And then we still have the fourth root of 5y cubed. And we can't simplify that any further. But remember, you can't have an exponent underneath the radical that's bigger than the index. If you do, then we know we can simplify. If we say this is the cube root of 40x to the 17th, I know I can take out some x's. Okay. So this is the cube root, x to the 17th, multiples of 3. What's the largest one? X to the 15th. How many are left? X squared. How about 40? Is 27 a multiple of 40? No. So 27 is 3 cubed. How about 2 cubed? What's 2 cubed? 2 cubed is 8. I don't want to use 4 and 10 because I'm looking for cubes. So if we start out 1 cubed, 2 cubed, 3 cubed, 4 cubed. What's 4 cubed? 64. Too big. 3 cubed, 27. You said it wasn't a factor. How about 8? Does 8 go into 40? It's 8 times what? 5. But we're not going to use 4 and 10. We're looking, if we're doing this, we're looking for the largest cubed as we go down. Now, if you wanted to, you could use 4 and 10, which is 2 times 2 times 2 times 5. What are we grouping by? For a cube root, you're grouping by what? 3's. So there's our 3 2's. 2 times 2 times 2 is 8. What's the cube root of 8? 2. The cube root of x to the 15th? X to the 5th. And then we still have 5x squared under the cube root. Alright. And we can't simplify it any further. But as long as we don't have any more perfect squares, cubes in here, and this is less than that index, we simplified as far as we can go. This is the fifth root of 2x plus 7 to the 34th. And you're not going to, this is not the same as raise that to 34, raise that to 34. If you wanted to multiply this out, you're going to be doing it for quite a while. This is 2x plus 7 times 2x plus 7 FOIL times 2x plus 7 distribute again times 2x plus 7 distribute again all the way up to 34 of them. Okay. But we're not looking to do that because of that power. We have a fifth root. What's the largest multiple of 5 that's in 34? 30. So this would be 2x plus 7 to the 30th. And then how many are left over? 2x plus 7 to the 4th. Notice how that power has to be less than the index. Now we can simplify this one. What's the fifth root of 2x plus 7 to the 30? Times the fifth root of 2x plus 7 to the fourth. You can't go any further. You're done.